limits involving radicals. So the standard technique when you see radical expression and you have limits, we will multiply the top and bottom by the conjugate of the radical expression. However, in this problem, we have two radical expressions that are not the same. So how do we deal with it? Well, we have to multiply the conjugate twice. So let's see. For the first expression, so we can deal with the one on the top first. The conjugate of the numerator is the same expression, so square root of 5 minus x, and you change the sign in between, so plus 1. So for the bottom, you multiply the same thing, so multiply square root of 5 minus x plus 1. So then you rewrite the limit, okay? X goes to 4. So I'm not going to carry out all the calculation, but the main idea of using conjugate is you have a minus b times a plus b, you get a squared minus b squared. So we have square root of 5 minus x, we square that, we get 5 minus x. So 5 minus x on the top, and then you subtract 1 square, which is just 1. So 5 minus x minus 1, it's just 4 minus x on the top. And in the bottom, you don't touch it, okay? You leave it alone. And the reason is because even if you expand it, you're not going anywhere. So you leave it alone and you do the conjugate one more time, and this time you do the conjugate of the denominator. Okay, so you multiply by square root of 29 minus x, and you see a minus 5, so you do plus 5. Okay, and in the bottom you do the same thing. So you multiply by the conjugate, so it's square root of 29 minus x plus 5. And then we will combine this term and that term using the difference of squares formula. So x approach 4. On the top, you leave it alone. Okay, so it's 4 minus x times square root of 29 minus x plus 5. In the bottom, you get, so you combine the 29 minus x minus 5, right? So you get 29 minus x, but then you minus 5 squared, which is 25. 29 minus 25 is 4 minus x. So 4 minus x. After you combine the two red underline expression, you get 4 minus x. And then you write whatever's left over. So 5 minus x plus 1. So then we see the cancellation. 4 minus x and 4 minus x cancel. Okay, so I'm going to use different color. So why? So you see, okay, the expression looks almost the same, except it just flipped. But this is the reason why it's solving the problem now. So if you look back, when you have square root of 5, okay, minus x, so you plug in 4, and then minus 1 on the top, and then you do square root of 29 minus 4 minus 5. So on the top, you have square root of 1 minus 1, you get 0. And in the bottom, you have 29 minus 4 is 25. Square root of 25 is 5. 5 minus 5, 0. You have 0 over 0, which is indeterminate, like 0 cannot be over 0. Sometimes it's 0, sometimes it's infinity, and sometimes it's a constant. So when we have this kind of situation, we have to transform the limits. Now in this case, after we transform the limit using the technique of conjugate, what advantage do we get? Okay, so when we plug in 4, you will see it works this time. Okay, so you get square root of 29 minus 4 plus 5. And in the bottom is square root of 5 minus 4 plus 1. So what you have on the top, square root of 25 plus 5. In the bottom, square root of 1 plus 1. Square root of 25 plus 5 is the same as 5 plus 5, so it's just 10. Bottom, 1 plus 1, 2. So you get the final answer, the limit equals 5. So this is how you approach a problem with two different radical expressions. Now, in general, or you want to check your answer. Okay, if you don't know, you have no idea how to get this analytically, at least you can try this. Okay, numerical approach. What you do is plug in x equals 3.99 using a calculator. And you also try x equals 4.001 in your calculator. And you will get an your answer will be approximately 5. So that also gives you a hint that this limit approach 5, even if you couldn't solve it analytically.